বুঝতে পেরেছো?
Yes, sir.
So shall I proceed?
Yes, sir.
Okay. So next is the code generation and code optimization. Intermediate code generation, as I told. Now it is the code, how to generate the code. The code generation is the final activity of the compiler. It is the process of creating assembly language or machine level language to perform the operations specified by the source program when they run the following properties. That means the compiler, the main thing of the compiler that will convert the high level language into the machine language or the low level language. And it will be run by the following properties. That is the correctness. It should produce the correct codes, high quality, quick code generation, efficient use of resources of the target machine. So this all these 4 jobs will be done by the compiler in the machine language. It will transfer this high level language into the machine language. Next, there are some design issues. Input to the code generator, target programs, memory management, instruction selection, register allocation, choice of evaluation order. So input to the code generator, the input to the code generator is the intermediate code. The intermediate code, along with the symbol table, it will use to determine the runtime address of the data objects. And target programs, the output of the code generator is the target code. That means that could be either machine language or assembly language. That means after checking the logic, when in order to after processing the result, and that time after conversion, that target programs occur. That after conversion into the machine language, this target program occurs. And next is the memory management, the place, the location where we want to save the result. The code generator determines the memory requirement using the symbol table requirement. As per the data structure, as per the program, what output we want, so how much space will be required, it will be determined by the symbol table, and when that particular drive, whether that space is available or not, that will be also determined by the code generator. Instruction selection, the selection of instruction depends on the target machine, and that means in which software we have used and what version, and output will be generated as per the instruction selection. Then is the register allocation. It is also associated with the memory, the address of the memory, in which drive it will be occur, and choice of the evaluation order. So these are the 6 design issues for the code generation process. Next is the code optimization. So code optimization is used to produce an efficient target code. That means as we know, optimization process, optimization means the best possible outcome. So so the code optimization it is used to produce the efficient target code, the final result what we're going to generate. So following are the issues. The semantic equivalence of the source program must not be changed. Next, the improvement over the program efficiency must be achieved without changing the algorithm of the program. Suppose if we want to update the program, we should not change the algorithm. We can suppose for the web page design, we can design the page by adding more inputs, or if we want to add some leaflets or the CSS script, we can do that, but we should not change the logic of the main program. And next is the local and global optimization. So if the transformation is applied on the same basic block, then this kind of transformation is called local or otherwise global. So what is the basic block? Actually a basic block is a set of statements that always executes one after the other. Actually this basic block can be represented by the directed acyclic graph. So basic block is a set of statements that could be executed one after one. In a program, you have written the program, and each and every statement will be executed one after the other, and it has only it has no branches, only the entry and exit. So this basic block, the source code, or the can be represented with the in a graphical form, which is known as the directed acyclic graph. So this local and global optimization this compile time evaluation. Compile time evaluation means shifting of computation runtime to compilation time. This is the compile time evaluation. After compilation, it will go to the that means computation runtime will be converted to the compilation time. That means for running time to execute the program will be converted to for checking the logic of the program, that is the called compilation time. In this case, the two methods are used. So one is the folding. In this computation of constant is done at the compile time instead of execution time. And next is the variable propagation, which means use of one variable instead of another. Example, b is equal to a and c equal to b plus c. So since b is assigned to a, we can write the expression as c is equal to a plus e. That's why it is saying variable propagation. We are changing. You can write similar variable instead of other. So these are the two process for the compile time evaluation. That is the folding process, and another is the variable propagation. So in the folding process, suppose if we say that I is equal to pi r square in the radius of the circle, if we consider this pi, it will be computed at the compile time either. This pi value will be 22/7. This value will be automatically detected by the compiler and will give the result. So that's why it is called as a folding. Computation of constant is done at the compile time. Constant is 22/7, pi value 3.14, that is the constant value. So this will be calculated by the compiler itself. So these are the two things, folding and variable propagation. So next is the code movement. The goal of code movements are to reduce the size of code, reduce the frequency of execution of code. So suppose if you see this example, for example, for I is equal to 0, I less equal to 10, I plus plus, x is equal to y star 5, k equal to y star 5 plus 50. The logic inside the for loop it has written. And so and this they want to, in order to reduce the size of the code, what they are doing, they are defining a variable z is equal to y star 5 and x is equal to z. That means x is equal to y star 5. Instead of writing x is equal to y star 5, then in short in the loop they are writing x is equal to z and k is equal to z plus 50, because z is assigned to y star 5. Just to reduce the size of the code, this code movement occurs. And also the loop execution will also be easier, because the loop easier and it will be simpler, because the z expression is already written outside the loop. Next is the strength reduction. Sorry. In the strength reduction technique, the higher strength operators can be replaced by the lower strength operators. That means, this is one example. In the loop, the for loop for I equal to 0, less equal to 100, count is equal to I star 2, and the same code they are written as count is equal to count plus 2. That means as start has more strength than plus operator. So in this way, as per the strength of the it will reduce the strength. Suppose I is 100 and count 100 into 2, it will be 200, and but if we write in the count is equal to count plus 2, and that means count is equal to 200 plus 2. So it will be star has the more strength than plus operator. Then multiplication, star means that multiplication has the more strength than the plus operator. That means these are the various way you can design your code in order to save the compilation time and all those things. That is the that's why it is called as the code optimization. Which way you can write the code, that is the either in the code movement form, which will reduce the size, or if you instead of writing a very big program, if you keep the logic in a short and write in the optimized way, so that will be the best concept. Because if you write 2-3 pages of long code, it will be time consuming, and also some the person who are not of the familiar with that language, they will be difficult to understand. So in the short, if you can write the code, that's why it is called as the code optimization. And the strength reduction also, it is also the memory allocation. If the size of the code is less, and it will be the memory will be also less required in order to save the program. Next is called as the date code elimination. So date code elimination, it is that a variable is said to be alive in a program if the value contained into it is used subsequently. On the other hand, it is said to be dead at a point in the program if the value contained it never been used. Suppose if you define a value, and if that value is or the function, it is subsequently called or it is be used, then it is okay. Otherwise, if that value if you have defined at the beginning and it is not been never being used, so unnecessary you have defined that variable and increasing the length of the code. So so that at the point of time the program is executed, that value is no longer required, so it is dead. That's why it is called as the date code elimination. So this is also one part of reducing the code. Unnecessary if you declared a variable which is not required, so it should be deleted. That's why it is called as a date code elimination. And next is the loop optimization. So loop optimization is a technique in which code optimization is performed on the inner loop by the following methods. One is the code motion. So code motion, we move codes outside the loop. If some expression lies in the loop, the result remains unchanged even after executing the loop several times. For this one example is given. In the loop x is equal to y star 15.